All right, what is going on, everybody? This video, it's applied calculus, but it's a review of trigonometry. So it's exactly what the title says. It is a review. It's not like I'm trying to teach you this stuff, because if I were trying to do that, this video would probably be about 8 hours long if I was trying to teach you every topic in this video. So this is just a review. All right, so let's talk about this angle here in standard position. So an angle in standard position, you've got your axis here. You can call this the XY axis. And an angle in standard position, the vertex of the angle is at the origin. The initial side runs along the positive x-axis, and then we rotate. So if we rotate this way, that's rotating in a positive direction. If we rotated back this way, that would be rotating the angle in a negative direction. Here's your angle theta, and this side here is your terminal side. All right. Now let's talk about converting degrees to radians and radians to degrees. So to convert degrees to radians, we multiply degrees by pi over 180, and to convert from radians to degrees, we multiply the radians by 180 over pi. All right, so let's look at some examples here. Convert degree measure to radians. So if we have 18 degrees, we're going to multiply that by pi over 180. And so that is going to give us pi over 10. Now, typically when we write our angle in radians, typically you keep it in terms of pi. No, you don't have to, but that's typically what you see. I mean, this is the same thing as 0.314 radians if you put it as a decimal. But you know, as far as how your teacher wants you to put the answer, I'm sure they'll tell you. A lot of times you just leave it in terms of pi. I know if you're taking my test, I would want it in terms of pi. And then if we have 315, that's going to be 315 times pi over 180. And so that is going to be 7 pi over 4. And there's your answer. All right. So that's going from degrees to radians. Now what about converting radians to degrees? All right, so we've got 2 radians. So if we take 2 times 180 over pi, that's going to be, let's see, that's 360 divided by pi. That's going to be 114 point, we'll round it to 1 decimal place, 114.6 degrees. Okay. And then the 3 pi over 10 times 180 over pi. So 3 times 180, divide that by 10, and that's going to be 54 degrees. All right. So hopefully all of it's coming back to you. All right, so I'm going to come back to this in just a minute. I want to come down here first and work this example. Converting from decimal to degrees, minutes, and seconds, and converting from degrees, minutes, and seconds to decimal degrees. All right, so here we have an angle measure in degrees, minutes, and seconds, and I want to convert it to a decimal. So that's 301 plus, now we got to convert the minutes to degrees. So that's going to be 16 divided by 60, and that's degrees, plus, and now I have to convert seconds to degrees. So that's going to be 23 over, now think about it this way. If I go from seconds to minutes, I have to divide by 60, and that would put this in minutes. Then I would have to divide it by 60 again to put it in degrees. So we're dividing by 3600, and that's degrees. And so that would give us 301 plus 16 divided by 60 plus 23 divided by 3600, and that would give us 301 point, we'll round it to 2 decimal places, 0.27 degrees. All right. Now we have an angle measure in decimals, and we want to convert it to degrees, minutes, and seconds. So we have 24 degrees, and what we do is we take this 0.92, so we take the 0.92 and multiply it by 60. That's going to take that 0.2 degrees, multiply it by 60, that's going to put it in minutes. So that's going to be 24 degrees, and then 0.92 times 60, that's going to be 55.2 minutes. And then we take the decimal here, this 0.2, so that's 24 degrees, 55 minutes. And then we take the 0.2 times 60. We're converting minutes. That's 0.2 minutes times 60 will give us seconds. And so 0.2 times 60, that's 12. So that's going to be 24 degrees, 55 minutes, and 12 seconds. And so there's converting decimal to degrees, minutes, and seconds. All right. All right. Now let's come back up here. And here we have an angle in standard position. So this is the initial side here. And here's your terminal side. And we're rotating. There's theta. This is your x. This is your y. And here's r. And so the trig function, sine theta, is y over r, y over r. Cosine is x over r. And tangent is y over x. And then you've got cosecant, secant, and cotangent. Now, you don't need to really memorize these. You need to know these. You need to know the sine, cosine, and tangent. Because if you know those, then you'll know these. Remember, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So you can see cosecant is just r over y. See, it's the reciprocal of this, and that's how it works for the rest of them. Okay? So let's look at this example. It says find the value of all trigonometric functions. Well, you can see here we have x, here we have y, and what we need is r. So what is r? Well, this is a right angle. So we know that r squared is equal to x squared plus y squared, Pythagorean theorem. And so r is the square root of x squared plus y squared. And I know it could be positive or negative, but remember r is always positive. And so r in this case is the square root of negative 2 squared plus 3 squared. And so that's the square root of 13, 4 plus 9. So r is the square root of 13. All right, so now we have sine theta is equal to y over r. So that's going to be 3 over the square root of 13. And then we would rationalize the denominator. So I'll show the work on this one on rationalizing the denominator, but I'm not on the other ones. You should know how to rationalize denominator. Multiply by square root of 13, numerator and denominator. So that's 3 square root of 13 over 13. So there's sine theta. And then we can get cosine theta. That's going to be what? Negative 2 over square root of 13 x over r. rationalized denominator, that's negative 2 square root of 13 over 13. And then we have tangent theta, that's y over x. So that's 3 over negative 2, so that's negative 3/2. All right. All right, so now we've got sine, cosine, and tangent. Now to get cosecant, secant, and cotangent, cosecant is the reciprocal of sine. Now, watch this. So I've got cosecant theta. Now, look, don't do the reciprocal of this one. Look, don't do this. Okay? Yeah, you flip the sign, you flip sine. But now you have to go and rationalize the denominator. Look at this. Instead of flipping this one, isn't this the same thing as 3 over square root of 13? It's the same thing. So why not just flip this one? So that's just square root of 13 over 3. And see, now you don't have to rationalize the denominator. And same thing here for cosine. Take the reciprocal of this one, not this one. I mean, they're the same thing. They're just written different. So this is secant theta is equal to negative square root of 13 over 2. And then cotangent theta would be negative 2/3. All right. All right. So hopefully all this is familiar to you. You should have taken trig. All right. Now, what about evaluating with a calculator? Here's an example. I've already written the answers down. What I would like for you to do here is just pause the video and evaluate all of this with your calculator. Okay? All right. So look at this. Sine of pi over 6 is 1/2. Remember, pi over 6, that's 30 degrees in radians. Remember, 30 degrees is pi over 6 radians. 60 degrees is pi over 3. 45 degrees is pi over 4. And then you got pi over 2, pi, 3 pi over 2, and 2 pi. That's 90, 180, 270, and 360. Remember, all of those, you're supposed to know those off the top of your head. You're supposed to know the sine, cosine, and tangent of all those special angles. So that's one you wouldn't put in your calculator. You would just know it's 1/2. I know that this kind of doesn't look like a 1, does it? But it is. That's a 1 right there. All right, and then the rest of them, okay, just type in cosine 23 degrees. Type in tangent 2.3. Now, on this one, you may have gotten it incorrect. And if you did, do you know why? Okay, so the reason some students miss this one is because when they type in tangent of 2.3, they still have their calculator in degrees. For this one, your calculator would need to be in radians. Okay? Notice there's no degree symbol here, so that means it's in radians. So you would have to change your calculator to radian mode and then plug it in. Now this one, cosecant of 133 degrees. Now, there's no cosecant button on your calculator. You have a button on your calculator that looks like this. Sine, and then above it is that. This is not cosecant. That is inverse sine. So you can't use that. So how would you evaluate these reciprocals, cosecant, secant, and cotangent? Well, you're going to do them, they're all done the same. For cosecant of 133, you would have to do this in your calculator. 1 divided by sine of 133 degrees. You would have to punch that in. For this one, you would have to do 1 over cosine of 5.7, and 5.7 is radians, so your calculator would need to be in radians. And then for cotangent, you would have to do 1 over tangent of 257.3 degrees. Okay, So that's punching it in your calculator, but remember you do need to know the sine, cosine, and tangent of 30, 45, 60, 0, 90, 180, 270, and 360. Okay, you need to know those. All right, reference angles. Remember, a reference angle is an angle that is a first quadrant angle. A reference angle is between 0 and 90 degrees. So if you have an angle whose terminal side is in the first quadrant, then that angle is your reference angle. This angle here with the little mark on it, that's just the notation I'm using for reference angles. You can see different textbooks, different trig textbooks use different notation. I just use the theta with a little mark right here. Some textbooks do this, some will use this, some will use this to represent a reference angle. Just depends on what book you're in. Okay. But then if your terminal angle is in the second quadrant, here's your reference angle. So how do we find the reference angle? Well, if we do 180 minus theta, that gives us our reference angle. Or if you're in radians, it would be pi minus theta. And then if we're in the third quadrant with our angle, then the reference angle is, see, that would be theta, and then you would have to subtract off the 180. Or if you're in radians, theta minus pi. And then if you have your angles in the fourth quadrant, then your reference angle is here. That would be, you'd have to go all the way around to 360 and then subtract off theta. Or if you're in radians, that would be 2 pi minus theta. Just remember, your reference angle is always measured off the x-axis. Okay? Like, in other words, this right here, that's not your reference angle. You don't measure your reference angles off the y-axis. An easy way that you can think of this is if you think of a, look at this. See if I can draw this. Think of a bow tie. These are your reference angles. Here, 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 and here. They're all measured off the x-axis. Okay, it's important you know how to do reference angles. And so here's some examples we have to find reference angles. What I would recommend doing is sketching your angle. Let's change colors here. All right, so here's 120. There's 120. And this would be my reference angle. Okay, so my reference angle would be 180 minus 120, which is 60 degrees. There's my reference angle. Now let's look at this one. So 7 pi over 6. Where's 7 pi over 6? It's right here. It's in the third quadrant, 7 pi over 6. Okay, and so this would be my reference angle. And so that's going to be what? My reference angle is 7 pi over 6 minus pi, which that would just be pi over 6 is my reference angle. And then for the 320 degrees, there's 320. Here's my reference angle. So my reference angle would be 360 minus 320, which that would be 40 degrees. All right. All right, so how about graphing? So if we have a function here, y equals a sine of bx plus c, or y equals a cosine bx plus c, the amplitude, that's how high and how low the graph goes. That's the absolute value of a, the absolute value of the number in front of your trig function. The period is 2 pi over b. There's b is in front of x here. And the phase shift, that's how much it moves left or right, is negative c over b. All right, so let's sketch the graph. And remember, if you have y equals sine x, then that graph is going to look like this. Pi 3, this is 3 pi over 2 here. I know it doesn't look like it, I'm writing small. And so we know that graph is going to look like that. And if you have y equals cosine x, that graph is going to look like this. That's 2 pi, 3 pi over 2. That's 3 pi over 2, pi over 2, 1, negative 1. So cosine would look like this, okay? I don't have time to teach you how to graph. I'm just refreshing your memory. All right, so let's graph this thing. So the way that I show you to graph is if you got sine or cosine, whatever you're taking the sine or cosine of, you take that and you put it between 0 and 2 pi, and you solve for x. So I'm going to subtract pi over 6 to both sides. And so that's negative pi over 6 less than or equal to 2x less than or equal to, let's say it's 12. That's going to be what, 11 pi over 6. And then divide it and then multiply everything by 1/2. So that's going to be negative pi over 12 less than or equal to x less than or equal to 11 pi over 12. Okay, so that's the period that I'm going to graph it over. We're going to graph it over one period. And look, if you're looking to, if you need to watch more videos on this, look at my trig videos. Just search my channel for graphing trig functions or graphing sine, graphing cosine. I got videos that go in way more detail than this. Okay, and so let's draw our axis. So I've got negative pi over 12, and I've got 11 pi over 12. And what I need to do is split this up into 4 regions. So I need the midpoint here. Remember how to get the midpoint? 11 pi over 12 plus negative pi over 12. That's going to be what? 10 pi over 12. And then I've got to half it. That's going to be what? 5 pi over 12. So that's 5 pi over 12. And then I need to add these. That's going to be 4 pi over 12, which that's going to be, let's see, 4 pi over 12, that's going to be pi over 3. So that's going to be pi over 6. And so we can see our y-axis is going to be about right here. There's your y-axis. This is your x-axis. And then I need the midpoint here. That's 16 pi over 12. And then that would be 8 pi over 12. Let me write it down. That's going to be 16 pi over 12. 16 pi over 12 times a half is 8 pi over 12. So that's going to be 2 pi over 3. So that's 2 pi over 3. Now, remember, let's say we've got 1, we've got negative 1. Remember, cosine starts out at 1, but since I have a negative in front, it's going to come, it's going to come down here. We got to start here at negative pi over 12. And then cosine goes to 0. And then cosine usually goes to a minimum, but since I have a negative in front, that's going to be a maximum, 0, and then it's going to come back down here. So it's kind of like it takes that cosine function there, and it just takes this and kind of flips it. Okay, but there's your graph. And hopefully I didn't make a careless mistake adding this stuff in my head. But basically what you're doing is you're taking these two values here, you're adding them up and then multiplying by a half. And that gives you this value. Then you need the midpoint between here and here. So you add them up, multiply by a half, and that gives you that. And then you take this value plus this value to get this midpoint, add them up, multiply by a half, and that gives you the 2 pi over 3. I don't think I made a careless arithmetic mistake, but If I did, then I did. Okay, I was doing it in my head. But the main thing is you get the idea how to do it. Okay, so that's graphing. And like I said, if you need more on graphing, just go look at my channel. I got a ton of videos on graphing trig functions. All right. All right, so now let's look at this. We've got some identities here. So I've got sine theta is 1 over cosecant, cosine is 1 over secant, and tangent is 1 over cotangent. Basically what these are saying is that sine and cosecant are reciprocals of each other, cosine and secant are reciprocals, tangent and cotangent are reciprocals. And then we've got tangent is sine over cosine, cotangent is cosine over sine. And then we've got our Pythagorean identities. You need to know these. Sine squared plus cosine squared is 1. 1 plus tangent squared is secant squared. And 1 plus cotangent squared is cosecant squared. And then you've got your negative angle identities. Well, we know sine and tangent are odd functions. Cosine's an even function. So sine of negative theta is negative sine theta. Tangent negative theta is negative tangent theta. And cosine of negative theta is positive cosine theta. Okay, so you need to know these identities here. All right, so let's look at this example here. So they want us to, I know I didn't write all the directions down, did I? But they want us to verify this identity here. So how are we going to verify this? Well, typically what you do is you take the more complicated side, which in this case we'll take the left-hand side. And we want to see if we can simplify this to this side. All right, so how are we going to go about doing that? Well, of course, there's probably more than one way to do this, but typically what I tell students is, you know, there's no one thing I can tell you that says, okay, do this every time and it'll work. Okay, you just can't do that when you're proving identities. But one thing that works a lot of the time is rewriting everything in terms of sine and cosine. Okay, so I just rewrote everything in terms of sine and cosine. And then what I'm going to do is I'm going to get a common denominator and add these together. See, this is just one term here. There's no plus sign in between them. So let's add these together. So my common denominator is going to be cosine squared plus sine squared. Whoop. Did I say cosine squared plus sine squared? I mean cosine squared times sine squared. Okay, I don't know if I said plus or not. If I did, I meant multiplication between them. And so what do you got to multiply to this to get the common denominator? Well, you got cosine squared, so we've got to multiply by sine squared. Here we got to multiply by cosine squared to get the common denominator, so we got to multiply the numerator by that. And so we get sine squared x plus cosine squared x over cosine squared x times sine squared x. Now, you need to show this step when you're proving or verifying identities. You need to show all the details, all the steps when you're proving something. Well, what's sine squared plus cosine squared? That's 1, right? That's from this identity up here. See, sine squared plus cosine squared is 1. And so we've got cosine squared x, sine squared x. And what we can do here is we can actually separate these like this. And so you can see, well, what's 1 over cosine squared? Well, that's secant squared. And what's 1 over sine squared? Well, that's cosecant squared. And there you go. You've got the right-hand side, secant squared, cosecant squared. There it is. And so that's verifying that identity. Okay. In order to verify the identities, you've got to know all of this stuff right here. You've got to know these identities here, and that's what you're using to prove these identities. And like I said, if you need to look at more on proving these trig identities, just search my channel for proving trigonometric identities. All right, we got law of sines, law of cosines. All right, so law of sines, here we have a triangle. So it's basically, it's this. That's your formula, okay? See, if you take this c squared is equal to a squared plus b squared minus 2ab times the cosine of angle C. This C here is this one. It's a capital C. This C is this side here. And look, it's these all have the same pattern, okay? You see the angle here and the side here, how they're opposite. This is the side opposite this angle. And then it's the other two sides squared minus 2 times the other two sides. Well, it's the same thing. Look, there's B, there's the side opposite. See, angle B, the side opposite. See that and that. And then it's the other two sides squared added together minus 2 times the other two sides right here. And that's the pattern of it, okay? And then you've got law of sines. That's, you have an angle. Side A is opposite angle A, and it's this is your law of sines. And basically you can take any two and set them equal to each other, okay? Just whichever ones you need to set equal to each other. I can set this one equal to this one, I can set this one equal to this one, or I can set this equal to this, okay? Just whatever you need to use. And some books will write the law of sines like this, and that's fine. I just typically always write it the first way I had it written. This is the same thing. Okay, you may have seen it like this, and that's correct too. Okay, you may have seen it either way, but that's the law of sines, law of cosines. We're not going to work any examples with them. Just refresh your memory. You should know how to do the law of sines, law of cosines. And like I said, any of the topics in here that I'm covering, you can search my channel for that particular topic, and I've got a video that goes in more detail. In applied calculus, we just don't go into the detail, okay? All right, now here we've got sum and difference identities. These you would just have to memorize. It's cosine, look at this, cosine A plus or minus alpha plus or minus beta is equal to cosine alpha, cosine beta minus plus sine alpha, sine beta. So what this means is cosine alpha plus beta is equal to cosine alpha, cosine beta minus sine alpha, sine beta. Or the other one, cosine alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. So if you're up here at the plus, you would have a minus. If you got a minus, you would use the plus. And then similar here with sine alpha plus or minus beta and tangent alpha plus or minus beta, you would have to know those. And then you got your cofunction identities. Sine of 90 degrees minus theta is cosine theta, and cosine of 90 minus theta is sine theta. All right. All right, so let's look at this example here. We want to show that this is equal to this. So let's see how we're going to do that. Well, we're going to take the left-hand side, which is sine of pi over 4 plus x times cosine pi over 4 plus x. So what we're going to do is we're going to use these sum and difference identities to expand each one. Okay, so let's expand this one. So that's going to be, let's see, we've got sine of pi over 4 plus x, so we're using this one. We're going to use the top one. So that's going to be the sine of pi over 4 times cosine x plus cosine of pi over 4 times sine of x. Okay, that's the first one here. Let's put that in parentheses. And then times, now I'm going to do this one, cosine plus. So it's going to be cosine alpha plus beta. So that's cosine cosine minus sine sine. All right. So that's cosine pi over 4 cosine x minus sine pi over 4 sine x. All right. And so now what we need to do is what? What do you think we need to do? We need to full this out. First, outside, inside, last. And so that is going to give us sine pi over 4 cosine pi over 4 times cosine squared x. So I did the sine pi over 4, cosine pi over 4, and then cosine x times cosine x is cosine squared. And then I need to multiply the outside. And so negative and a positive, that's going to be negative. That's going to be sine squared pi over 4. And then that's going to be, let's see, sine x cosine x. And then the inside, so that's going to be plus cosine squared pi over 4. And that's going to be sine x cosine x. So if I don't run out of room, and then multiply the last. So that's going to be sine pi over 4 cosine pi over 4, and then sine squared x. I don't think I ran out of room. I know that looks messy. But then, let's see, we've got what? We've got square root of 2 over 2 times square root of 2 over 2. That's this, and that's going to be cosine squared x. And then I've got minus, and then sine of pi over 4, that's square root of 2 over 2, and that's squared, times sine x cosine x, plus, and then I've got square root of 2 over 2 squared, and that's going to be sine x cosine x, minus, and then I got square root of 2 over 2 times square root of 2 over 2 times sine squared x. All right. And so, well, that worked out nice. Look at this. You see how that term and that term cancel out. And so I am left with, that's what? Square root of 2 times square root of 2 is 2. So that's 2 over 4, which is 1/2 cosine squared x, minus, and then same thing here, 1/2 sine squared x. And then I can do what? Factor out a half. And that's going to be cosine squared x minus not 1/2, minus sine squared x. And there it is. There's the right hand side. Okay, so that was just using those sum and difference identities to do that, to prove that. All right, and so here now we have double angle and half angle identity. So double angle identity, sine 2 alpha is 2 sine alpha cosine alpha. And then notice here for cosine, the double angles for cosine, there's 3 different ones. Which one do you use? Well, it depends on the information you're given. I mean, if they ask you to find cosine of 2 alpha and they tell you what sine is, then you would use this one. If they tell you what cosine is, then you would use this one. Okay? If they give you sine and cosine, you could use this one, or you could just use one of those. Okay? And then we got tangent 2 alpha. And then we've got our half angle identities. Sine alpha over 2 is plus or minus. Square root 1 minus cosine over 2. Cosine alpha over 2. It's the same thing. It's just got a plus instead of a minus there. Okay, so that's your double and half angle identity. So just to remind you of those. So let's look at this. It says, knowing that cosine alpha equals 3/5 for an angle in the fourth quadrant, so alpha's in the fourth quadrant, find the sine of 2 alpha. All right, so the way I would do this is I would write down sine 2 alpha is equal to 2 sine alpha cosine alpha. Okay, so that's the formula. So we look at this and we say, okay, what all do we need to find sine 2 alpha? Well, we need to know what sine alpha and cosine alpha is. That's what we need to know. But notice we already have cosine alpha. See, we already know this. So we need to find sine alpha. So we would come over here to the side, and we know sine squared alpha plus cosine squared alpha is equal to 1. And so that's going to give me sine squared alpha plus, now in the place of cosine alpha, I'm going to put 3/5. So that would be 3/5 squared equals 1. So sine squared alpha is equal, not equal, plus 9 over 25 equals 1. So sine squared alpha is, now remember I would subtract 9 over 25, so that's going to be 16 over 25. And so I get sine alpha is negative 4/5, or sine alpha is positive 4/5. And we know that's not the solution. It's this one. So how do we know that? Well, because our angle is in the fourth quadrant, and we know sine is negative in the fourth quadrant. And so now I have sine of 2 alpha is equal to 2 times negative 4/5 times 3/5. So I get sine 2 alpha, what is that, negative 24 over 25. And there's sine 2 alpha. Okay, and you would work any of them the same way. Whatever they ask you to find, just write the formula down and see what you need to plug in. You know, just like I did here. And if you don't have everything, well, you need to find it. There will be a way to find it. Okay. All right, arc length and area of a sector of a circle. I believe this is the last topic here. So arc length, you've got a central angle. That means the vertex of the angle is at the center of the circle. And so the arc length is S equals R times theta. S is your arc length. R is the radius of the circle, and theta is your central angle. And it is important, notice this right here. Theta is in radians. Okay, same thing, area of a sector of a circle. We're looking for this, that area right there. So you got your central angle theta, you got your radius R, and theta is in radians. All right, so let's look at some examples. Find the area of a sector of a circle with central angle 218 degrees and a radius of 5.25 inches. So we're looking for the area of a sector of a circle. So A is 1/2 theta times R squared. All right. So we know R is equal to 5.25, and we know theta is 218 times pi over 180. We've got to convert it to radians. And remember, we did that at the very first of the video. So let's see, 218 over 180. Let's see, what is that going to be? Well, it's kind of a, well, it'll simplify to 109 pi over 90. And so we plug everything in. And, you know, I guess if you wanted to, you could put that as a decimal, but I don't think I would. I think I would put this in and square it. I would just type that into my calculator and square it. So that means you're not rounding. You won't have an error there. And so, well, I'm sorry, not square it. You don't have to square that. I was looking at R when I was talking about that. No, you don't square this. So that's times 109 pi over 90 times 5.25 squared. And so let's see, what would that give us? That would give us 52.4, and what unit is that? Square inches. We're looking for the area. The radius is in inches, so that would give us square inches. All right. So it says the area of a sector of a circle is 75.5 square feet, and the radius is 12.2 feet. Find the central angle. All right, so write your formula down, and we're looking for theta, right? Did they give us information for everything else? Yes, we've got 75.5 equals 1/2 times theta. That's what we're looking for, times 12.2 squared. Just plugged everything in. So let's see what we can do to kind of clean this up. Let's see, what is 12.2 squared? And so this right here is 148.84, and then I'm going to multiply it by 1/2, and so that's going to give me 75.5. So the 148.84 times 1/2, that is 74.42 theta. And then I divide everything by this, and so I'm dividing by 74.42. And so I get, let's see, 75.5 divided by 74.42. That gives me 0.15. Let's round it to that. And this would be radians. Remember, that's radians. The theta you're finding is radians, which we could put, or theta is 1.015 times 180 over pi. We can convert it back to degrees. So let's see what we get. 1.015 times 180 divided by, see, then where's pi? Divided by pi. Or we could write 58.2 degrees. Let's see, 1.01. Make sure I did that right. Yeah. Okay, so yeah, the book that I'm using, it had 57.9, but what I noticed is the book rounds this just to 1.01, and I rounded it to 1.015. 0.15. Let me try that again. Do that one more time. Times 180 divided by pi. Yeah, 58.2 degrees. All right. So that is the end of the video. That was just a quick review of trig. All right, I know this is calculus, but it's important that you know your trig. So I hope the video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I will see y'all in the next one. Later.